Good morning, ladies and gentlemen. Now we are about to start. Again, I hope you all had a great dinner last night. I for sure had. That's why my voice is the way it is at the moment. But I'm very, very happy to welcome you to our third keynote session for this morning. As a matter of fact, we will have 3 keynote speakers in this session, and I'm very much looking forward to all 3 of them. I think the combination of the 3 topics is fantastic. And I hope you will join me after this session to, well, really have enjoyed this session and the presentations. We will start with Isabel Hilliger from, you can come up here already, yes. So Isabel, and I needed to note that down, I'm sorry, I don't have it off the top of my head. So she's Assistant Professor of Practice and Assistant Director for Assessment and Evaluation at the Pontificia Universidad Católica de Chile. She holds a PhD in engineering from PUC Chile, and she also holds a master from Stanford. And in her presentation, which is called Adapting Curriculums to Technological Change, Leveraging Learning Analytics for Skill-Based Education and Continuous Improvement, she will introduce us into her work, and I think the topic is fantastic, and I'm looking forward to that. So welcome here on the stage. Take it away.
Thank you, Dominic, for that introduction. And yeah, that's me. My name is Isabel Hillier. This is my first time in this event. As Dominic mentioned, I'm an assistant professor of practice at the School of Engineering in Pontificia Universidad Católica de Chile, and I have recently assumed a new role as well. I have traditionally been involved in management regarding the assessment and evaluation of competencies within my school, but I'm also running now an engineering design unit that is called DLAB, and I'm really, really thankful for being here, and I would like to thank Manuel Morales and all his team and all the team that has been involved in hosting this conference here in Chile. So yeah, this is the title of my presentation. It's about adapting curriculums to technological change. And in order to do that, my subtitle is Leveraging Learning Analytics for Skill-Based Education and Continuous Improvement. That is my line of work. So just a quick agenda. I will talk about briefly about the context regarding skill-based education, regarding learning analytics, and then a research objective that has guided my work, and then share with you some case studies, some examples of what I mean when I'm saying leveraging learning analytics for continuous curriculum improvement, and then some final discussions and implications. And as I know, there will be time for questions, but at the end of the 3 presentations. So any burning thought, please keep it there, write it down, and we can discuss it later. Okay, so now about the context. And I would like to start highlighting the importance of skill-based education. I assume that regarding this conference, there might be a lot of people around this. So what we understand as skill-based education, and there's this definition that has been recently coined by someone involved in generative AI research, and it's about the development and evaluation of specific skills rather than solely theoretical knowledge, so as to ensure an holistic learning experience for higher education students. How we could we reflect about this or make it simpler, like this definition, and it could be like related to hands-on practice and real-world application of the knowledge that we transfer to students. And I would say that the institution that we're right now, Duoc, it's really well known for doing this very well. But sometimes research-based universities, like the one that I'm part of, we struggle with this tension between knowledge and applying knowledge. Traditionally, skill-based education has been associated with face-to-face teaching. And this, we might already know that it's not necessarily the current paradigm, but if we think about education for a long time, you will think about exemplary face-to-face operational teaching. So it would be someone that is an expert about a procedure, and it will show the student how to conduct the procedure. So for example, I have collaborated with people in health science education, and within my research, so there it's not that easy to see, but for example, in the context of physiotherapy, you could have a procedure that could be, for example, endotracheal suctioning, that it's like when you have to make the respiratory areas easier to access, and someone will show how to do it, and then the student will perform the procedure in face-to-face to that instructor, and then the instructor will provide feedback to the student at that moment, explaining what might be common mistakes that he or she had already performed, etc., etc. Still, there has been a paradigm shift because now we have the possibility to integrate online components or resources, and the idea is to do it in a reflective way, so that combination could actually leverage or improve or increase the amount of learning opportunities that students have in order to demonstrate the mastery of a skill. So for example, within the same skill procedure that I mentioned earlier about endotracheal suctioning, here we can see, for example, this is a feedback-based platform. So in the screen above, there is an instructor showing how to do it, and then there is the student taping herself about doing the procedure, and she can do this as many times as she wants and submit these videos, and then the instructor can give a lot of feedback about how the procedure has been done, so in order to master the skill. And this is part of the work that has been led by a physiotherapy professor within our institution. It's called Ignacio Villagran, but related to a feedback-oriented platform that it's called C1 Do One, that it's also a Chilean edtech company. The interactions that now we can have of students performing skills and interacting with online resources as they do that gives us a lot of trace data. That is data generated when students interact with online resources, and that has been seen as something that can be leveraged to understand better how students can improve skill mastery. There has been a lot of research lines that have tried to leverage existing data, and learning analytics is one of them. Have you heard about learning analytics? I assume that yes. I see a lot of nodding faces. Thank you for that. And the Society for Learning Analytics Research has defined learning analytics as the measurement, collection, analysis, and reporting of data under context in order to understand how students learn and the environment in which it occurs. And actually this definition that was coined in 2011, and I'm citing the website for today, it's now being discussed because now the lines between trace data for just analytics are blurry because of all the emergence of generative AI. So that's something else. So one thing was to have online resources in order to increase the amount of learning opportunities for students to develop skills. But now actually we have generative AI that you had it for a long time, but now people that are not familiar necessarily with coding and everything, we can access through it with interfaces that are easier to use for us. And so now this emergence is highly influencing both education, research, and practice. So it's not only that we can learn by video and instructors can give us feedback, but also now there is all these machines and agents that can help us. And now there is a new paradigm of understanding hybrid learning. It's not only about the meaningful integration of online resources, but also about how much we want to transfer from our teaching to a machine, and how much it's meaningful that we do it ourselves, like humans. And actually, this diagram was inspired from the autonomous vehicle industry, and it was transferred to education. This is work from Inge Molenaar from the Netherlands, and it's in order to trigger this discussion about how much should be done by the teachers, and it's important to keep the human in the loop, and how much should be done or could be augmented or supported by the machine. And this generation or explosive growth of generative AI, it's opening new possibilities regarding learning analytics and learning outcomes and skill attainment. So this is kind of like the context that it's inspiring my work, but also has inspired this talk. And now I will start talking slower because I speak very fast, in order to talk further about what is my research objective inspired by this context. And for me, it's important now to evaluate the perceived usefulness. So one thing, it's the promise of learning analytics and trace data in order to understand skill-based education or support it. But other thing is if it's actually useful to measure competencies or skills in order to formulate curriculum improvement actions. So we improve the study plans that we offer to our higher education students. And to do that, to meet that research objective, what I'm doing right now is cross-analyzing different case studies. So there are different institutions that have been working with analytical tools to both measure and analyze skill attainment. And I have been examining how the use of these type of tools actually drives curriculum improvement. So far, I have been studying my own university, but I have a collaboration with Tecnológico de Costa Rica, which imparts different engineering careers. And so regardless of being in two separate territories, being part of Latin America, but still being really different institutions, we are more research-based. They are more like teaching motivated, and we are more in the engineering side, like more driven from research, and they are more in the applied side. We have one thing in common. That here it's the contrast still. So for example, in our case, we're a private institution, a really old institution, and they are like a public institution, and it's a more recently created. We have similar student enrollment, but we have a really different ratio related to the number of teachers per student. So it's really contrasting cases. But as I mentioned earlier, we have something in common that helps us to actually meet or explore our research objective. And what we have in common is that we're interested in continuous curriculum improvement, both because of intrinsic motivations to improve our programs, but also because of external requirements from accreditation agencies that motivate to actually assess and evaluate skills in order to improve the programs. And how we could understand continuous curriculum improvement, and it would be the systematic assessment of skill attainment within specific courses. So with one test that covers all the students. Also, not necessarily tests are the best assessment method to actually measure a skill, but it would be within the courses or subjects that we teach, how we can assess how students perform a particular ability. And within the assessment methods, what we actually use is direct assessment. So within skill assessment, there is a lot of types of approaches that have been used. Even people would talk about grades or like examinations or even performance appraisals that could be what the teacher perceives that the students is doing. But in this case, the idea is that you have an artifact that could be an assessment and a rubric in order so the teacher can assess directly by observing the student doing the procedure if the procedure is well met and is showing the skill that the student is supposed to master. What skills are we assessing? This is just an example. So for example, in the case of Pontificia Universidad Católica de Chile, and I say all the name because we have different pontificias and sometimes people get upset because we just use the shorter version, but yeah, our institution is like assessing different skills that are related to what is motivated by, for example, the AVET accreditation agency, that it's a North American agency that accredits engineering careers worldwide. And in a very succinct definition, we're looking at, for example, technical skills, could be problem solving or data and experimentation, but also transversal skills like teamwork and communication. And this is common also with the case of Tecnológico de Costa Rica. In the case of Tecnológico de Costa Rica, they have skills that have been proposed by both the Canadian Engineering Accreditation Board, but also a local board that accredits programs within that country. And there is some common skills. So for example, there is a common focus on problem analysis and design, but they have also other types of skills such as social responsibility or knowledge application, not necessarily coupled to problem solving. How we can assess these skills? What we have so far, we have analytical tools. Both institutions have analytical tools to support this process. So for example, what you're seeing here is a screenshot of a tool that it's connected to our learning management system. And at a curriculum level, you have what you might call as a graduate profile or a list of expected skills as the one we see in the previous slide. And what we do is through a tool, we assign those skills to a specific courses. So for example, this is a course that I teach. It's called Anthro Design. It's about user-centered design or human-centered design. And here in a tab, it says I have 2 skills or competencies. This detail of the competencies is data and experimentation and lifelong learning that you saw it in the previous slide. And what I have to do as a teacher is that I have to find through a constructive alignment process and with the support of professionals within the engineering education unit, I have to properly align these skills to specific assessment deliverables that I have within my course. So for example, I would say that in the case of data and experimentation, there are different performance indicators. One would be to develop a protocol to collect information, and there will be another one in which I analyze the information collected. And what I can do is that within specific reports of my students, measure the capacity that they demonstrate in that report about these 2 skills. So you would ask yourself, well, how could you do that, but in a way that it's comparable across courses or across programs? And that could be simply a rubric where you establish, for example, this rubric, it's not necessarily about the skills that we saw before, but it's about communication. So you grab a very big skill, but then you break it into performance indicators that are actually easy to observe within a course. And you say which are the ones that the course can and a specific assessment method can actually measure. And then you establish scores in order to point out if the student is capable of meeting the indicator that is described there, or minimum requirements, or performs satisfactorily or exemplary, etc., etc. So the tool associates this rubric to the assessment method that has been aligned to a competency. And then that facilitates the fact that we can obtain reports like this. So for example, here we see different courses, the student enrollment, then how many students have approved the course, and then what is the percentage of achievement or the grade average of the points obtained through the rubric, and then also if it's a certain improvement plan it's needed or not regarding how much students attain the skill. So here, typically, the traffic sign type of thing, we have in red something that it's a mean that it's below what it's expected. As for example, 3 would be that they meet the requirements, and it's because it's below 3, it might be required that the teacher or the course instructor with other colleagues to discuss why students did not meet the skill. And you will have all the evidence regarding, well, I chose a specific assessment method, and what happened is that maybe the assessment method was not properly designed. Maybe students didn't have the prior knowledge that the course instructor expected, within that course. Maybe the context has changed, maybe many things happen. So at the end, those conversations between the instructor and his or her colleagues would be really valuable in order to formulate improvement actions. And you could ask yourself, well, what type of improvement actions have emerged in these two universities doing this effort of connecting tools with the learning management system and constructively aligning assessment methods with indicators of a specific skill? And these are some of them. So for example, sometimes it has triggered conversations about pedagogical innovation. So for example, would say, okay, we're expecting students to perform a skill better, but we're not including some active learning experiences that would be valuable in order to actually help students to master that skill. Or so maybe we need to change teaching methods. Or maybe there have also been discussions around, you know what, the assessment methods that we chose, it was not the best one in order to actually observe or measure the skill. So changing assessment methods. And even it could be a discussion broader about, are we actually assigning the competency in a proper way to this course, or there is another subject that actually it's better to demonstrate the attainment of this skill? So that would be a pedagogical innovation, but at a study plan level or at a curriculum level. Also, teaching staff have become more conscious about how they plan their courses. So it would be, you know what, I implemented this assessment method, but students actually at the end of the course get better about doing this. So maybe it would be better to, for example, for them to give them all these learning opportunities before demonstrating the skill in this assessment instance. So in order, for the next semester, I will improve the instructional design or how I have planned my course. A third piece is that all the teaching staff have become more conscious about the holistic experience. Or like one thing is to expect students to do things, but also it's like how this interacts with other courses. What happens a lot to us is that we think about our individual course, but we have a scarcity of time in order to discuss with colleagues how we are ensuring that all the courses are helping to develop specific skill. So it has triggered those conversations as well. And also what has happened is that teaching staff have discovered opportunities to improve their teaching skills. So actually they say, okay, we're expecting students to communicate well, and we are measuring that, but actually we have needs to improve our communication skills, so we're better role models for our students. So maybe now we know it's like a grassroots effort in order to communicate to the institution. We need more teacher development, but focus on this, not generally about pedagogical skills. So those are some findings that we have already had, but if we, based on the cross-analysis, what I would say that has been common in the two contexts is that it has been perceived that and we conducted interviews with people like faculty, teaching staff, developers behind these analytical tools, and also program coordinators, people that are faculty and act as program chairs, or people that support, professionals that support teaching endeavors. And by talking with these people and triangulating with some documents that have evidence about how this process has been enacted in these two university settings, some things that are in common in both institutions is that one, direct measurement of skill attainment has been useful, and it has been particularly helpful to have an analytical tool, because then what is obtained is that we're not doing an extra effort for accreditation endeavors or things like that. Like the course itself helps us to obtain a sub-product that we can use for accreditation, but because the skill attainment is related to a course and the course is related to the curriculum profile, you can trigger better conversations about how to improve the study plan or how to improve the graduate profile. Also, really simple curriculum analytics visualizations of skill attainment have been useful to formulate improvement actions. So people have been able to use really simple tables and charts about the percentage of students that are attaining a skill, not necessarily a grade. And by looking at those charts and tables, having conversations that have triggered the improvement actions that I presented before. Like we need some faculty development that is focused on a specific topic or skill, or we need to change how we are assessing a specific procedure. And finally, as we saw, different improvement actions have emerged from the process, and regardless, we have not demonstrated that those improvement actions have translated in order to better learning. At least there is a system that is systematic and that is sustainable for a long time. And now to end, some discussions and implications that actually there might be some concerns that you have regarding my talk, and also some things that I'm thinking about regarding future work. So one concern could be, well, you have talked about developing those type of skills. Some are more technical, some more professional, but with this fast-paced technological context, these skills get expired all the time. You see in LinkedIn like these lists that are like, okay, now the skills that are more important are this. No, tomorrow are that. And so what do we do about that? Like skills that are important change all the time. And there, for example, something that I'm thinking about, and I saw a talk in Tech of Monterrey conference of the Burning Glass Institute, is that now there are also other technologies that help you to think more quickly about the skills that we are required to need. So for example, in the case of the Burning Glass Institute, they are doing like scrapping within the web in order to see, well, what are LinkedIn saying, what employers are saying, like in a faster way that institutions are capable of doing that. So they can do reports about, okay, maybe we need to give a deeper thought about the skills that we are proposing for the curriculum profile in order to rethink our programs, or actually this relationship between skills and courses. So that might be one potential line of work. Another concern could be, is this the best way to assess skills, like within our course, within a specific assessment method, and a rubric in order to show that a percentage of students are attaining or not attaining the skill? And well, there are platforms as the one that I mentioned before, that it's called C1-1, that maybe had better trace data about how in a specific moment the student is doing a specific thing, and we can give them feedback in a specific step that is related to a procedure, that is related to a skill. So maybe, and now so far, so they had this in order that instructors could give feedback to students regarding specific steps. But even they are going further, that they have generative AI agents that are improving the quality of the feedback that instructors provide. So it's not necessarily removing the instructor, but augmenting their capacities in order to improve the quality of their feedback. So it's more actionable from the student regarding a specific step in a specific procedure, so skills are better performed. So that'd be another potential line of work emerging from this process. And a third and final concern would be, well, you mentioned specific improvement actions, but you didn't demonstrate that these actions improve student learning. So why this would matter in a way? But then that's kind of like what the continuous improvement process is about, is that you map what skills should be related to specific courses within a study plan, and then you assess them, and you have data, and you discuss that data and do an improvement action, so you can assess, again, if the improvement action actually improved the percentages of skill attainment. And because if we do this systematically, we can evaluate if improvement actions actually improve student learning. So just as a final message, skill-based education, regardless it's like here for a long time, it's even more relevant considering the technological context that we are today, because it also forces us to reflect about how much we want to keep human and how much we want to keep automated. So saying that, this is kind of like the resources that I use for these slides, and these are some of the references that I quoted during the presentation, and this is my contact information. I will be available for questions at the end. Thank you.
Yeah, so we do have some time for questions. First of all, thank you very much for your inspiring talk.
Hi, Isabel. Thank you for the excellent presentation. I just was wondering about who is validating your metrics, because at the end of the day, are the employers and their headhunters, the one that get. And I don't know if they are measuring what you were put as a skill. Maybe they don't care about that skill, another one. So the only way to measure that is how many of your students get a job, independent of what we are measuring. So we have to see the assessment center of the employers.
It's up to one of the concerns that I've shown. I will see if I go get quickly, but I will use your questions in two ways. One way would be, so we have a piece where, I'm getting there. Yeah, there. So one piece would be, in order to validate what we are measuring, we need to have this rubric. This rubric has been also how you unpack a competence. You should like validate it with, at least you could see, like we have done like a 3-judge process in which people validate, like experts validate the rubric, and those experts could come from higher education institutions, but also from the industry. That would be one piece, the rubric. But as I say, from your question, you are like questioning this. Like maybe you're developing this, but the industry wants that. Today, what happens is that within the accreditation agencies, you have these professional bodies that represent what the industry expects in order to provide that information easier to institutions. So I would say that maybe this is one way in order to address your concern in terms of like, one thing it's like searching from the web. Another is to keep the industry close, leverage the existing technology to have more information and faster information about what the industry wants. But other thing is to bring that people on board and not necessarily rely only in these like entities that provide you information throughout accreditation agencies. That would be I anticipated that concern. So I see your question, but we're slow institutions. I think that it's good to have that people on board in advisory boards, within courses, etc. Thank you.
I really like what you're doing. My question is around, and thanks for the presentation, how is the staff buy-in? Do they see the value in what you're doing? And I guess second part to this question, how do you engage them in the process? How do you make sure they value what you're doing?
Thank you. I think that it's interesting because the questions really tackle the tough parts that are not that shown within the presentation. Yeah, there has been, I would say that within the teaching staff, you can see there's people that really see the value right on their own, they will buy in. But if they see of like, oh, this is I need the additional report among all the other things that you're asking me, as like having more students, more courses, more research, they will resist. So there's people that really see the value, about still, regardless of all the administrative work, program chairs, for example, that are faculty, or they see like, well, these are conversations that we actually need to have. Like, there might be more work, but we can, like, we should be, like, we have an industry that does continuous improvement, we need to do continuous improvement of our teaching as well. Faculty that do not have those managerial roles are more resistant. But if you demonstrate that there's a lot that the tool can do for them, they will be more likely to buy it. So yeah.
All right, I think we're dealing with that. Are you staying with us even after this session for more questions?
Yeah, sure.
Okay. So let's give a second round of applause to Isabel for that. And with this, I would like to ask the next speaker down to the floor here. I don't know, we're using your computer, right? We are using your computer? Okay, well, it's taken care of, perfect. So our next speaker is Luciano Chang Sanchez. And Luciano Chang Sanchez also is from the Pontificia Universidad Católica de Chile, and he is professor in the Department of Mechanical and Metallurgical Engineering. He also served as a visiting professor at the Carnegie Mellon University in Pennsylvania. And in his talk, he will talk about one of my favorite topics, remote laboratories, and he will talk and show us his experience, his work, his research in exactly this area, and he will also tell us how remote laboratories can improve teaching and how he uses that in his work. So let's welcome Luciano Chang Sanchez to the stage here. Thanks for coming.
¿Qué es lo que vamos a hacer acá? El carrito, ¿qué podríamos hacer con el material? Súper. Para ello tenemos...
Okay. Okay. Perfecto. Okay. Okay. Thank you very much. Good afternoon. Hello. ¿Se escucha? Hello. Hello. Okay. So my background is I am an engineer specialized in mechanical engineering and electrical engineering. This is very good for making these systems, which are usually a mix of, we call it also mechatronic systems, which are mechanical engineering based, but with a lot of integration of electrical engineering, electronic engineering, and computer science. Okay? So the concept is quite simple, especially in a country like ours. Our most advanced technology industry is mining. And in mining, they use huge equipment, very sophisticated, and vocational training in Chile has to prepare these people to go and operate these, maintain them, and manage them, and so on. And so this is very difficult because, of course, ¿Se escucha? Yeah. Okay. And so it's very difficult to train technical people and engineers for of this huge equipment, which is 20, 30, 40 million dollars of cost, and you have to train them, and then after that you have to have maintenance crews, and as I said, and management and so on. So how can we train people so they get to their job and they don't have to see this equipment for the first time when they get to work? So the second best thing would be to have a laboratory or that could be accessed by the student, which would prepare him so that when he gets to the field, he will not have too many things that he doesn't know about. Oops. Oops. Okay, here's more or less a project that we have that you can a skeleton of a project which is common to all of these things that we're trying to do for education and also for practical industrial projects. For example, here we have is this a laser? Okay, here we have a set of sensors which we integrate to this machine, and then these sensors send their information by wireless means to the internet. And then through the internet, it gets to a computer in which there is a user. In this picture right here, I show, for example, a box with all these things integrated, with these things integrated, okay? And this is the kind of signals that we would get. For example, they would show you the accelerations of points of the machine. They can show what the driver or the operator is doing, and so on. Here we have, these are actual projects. What I will show you today are actual pictures taken from actual projects that we have done. So this is, for example, another electrical shovel in which we mounted several sensors to monitor and to know what's going on. And first we did this not for educational purposes, but for operational purposes. But then came the aspect of trying to apply these things to education. So, for example, for these kind of shovels, which I tell you they are very critical in the mining industry, we decided to scale down a shovel, and we installed this in an institution where a young student could go and operate it and learn what the commands are and what is the response. He would have a feeling of what is the response of this system, because it's not theoretical. The system has a dynamic behavior. It doesn't react immediately, and sometimes it cannot obey the command because of certain alarms and so on. And so we built this. We show here we built this specially, and we took it to this institution, and so young students could go and work with it. That was the first step. So they didn't have to go to the mining industry, and they didn't have to get to teaching and training. And this was, we applied to funding from the government, and we obtained funding to do this so that we could generate virtual and remote labs for teaching certain disciplines. For example, here's another application. We have a robot, and we have, why do I say virtual? It's because even though we have laboratory equipment operating, it's still not safe to give all the control to the student, because somehow, because of unforeseen events, could damage the equipment. So it's better for the student to start at a previous phase in a simulation software. But in this case, what we did, the simulation software is physics-based simulation. So we have a model that is physics-based. It's Newton-Euler equations, so that if I try, for example, to accelerate too much, the system will not accelerate because it has to obey the laws of mechanical systems. And so here we have a user interface. He gets into his computer. This would be a student now. And through his computer, he can access the software, which we call PadRob, and that's a simulation base. So we have a physical system, and we have a model which is exactly the same physically, at least to a high degree, to a high fidelity. We call them high fidelity models. And so he first attempts to realize the task that he has to do in the simulation. Once he goes through that stage, he can connect afterwards through the internet to the robot, to the actual robot, okay? And so we apply this for teaching robotics because, of course, robotics are still expensive and not too many schools will have them available, especially vocational schools, which are the poorest in the country, I would say, in terms of, sorry, salesman. Forgot to turn it off. Okay. I'm going very slow. I hope I don't bore you. Okay, here I have a slide where I show this would be the user interface. Once the student has had the authorization to access the real robot, which is in a lab somewhere. So he types in the commands, which would be in a command list that he has available, which are similar or exactly the same as the commands that the robot is designed and built to obey. You know, the manufacturer has an interface, probably a computer interface, and so these commands he can write them in this screen, and anything that happens will be written in this window. Okay. Here's another setup that we developed, which we developed this one for hydraulics and one for pneumatics. And basically are the same. Hydraulics and pneumatics are very similar to each other, except that on the amount of force and power that you handle, but they are very similar in terms of handling and controlling. And again, we have the real equipment, which is above there, and then we have the sensors, and then we have a computer that interacts with the sensors and with the actuators. And then we have a user here, which is doing a slightly different thing. He is commanding the equipment using physical handles. So he will observe in his screen what it's doing. So it's not by text command; it's by actually using the handles that govern the actuators in this system. And this was done for pneumatic and hydraulic system. We had this operating for several years in our university, okay? And and so so we applied the same scheme to this kind of technologies that we want students to learn before going into the work. But you would have to apply a certain force, and you would have to set what the force is, and the system will react to that force according to the physical equations, in this case, Newton-Euler equations. And then we had to develop client-server applications in internet, okay? There's two technologies. One is using web servers, which is what we as users use normally, but that's not too good for the speed of response of the systems, because when you're using a web server, the web server can put you on hold, it can have some conflict, and many types of conflicts. So we use socket servers, which gives us a direct connection. It's a server, just like a web server, but it's a different technology. It doesn't have so many features, so it's very fast and efficient. And then and then one thing that helped even more was that the Internet of Things appeared. Because when we were doing these systems, sensors were very expensive. Data acquisition systems were extremely expensive. But with the Internet of Things, which means basically that, according to me, to my practice, just means that the sensors are very cheap and the computers are very cheap. And that's what happens. You can find an accelerometer that costs less than $1 today. And they used to cost $1,000 20 years ago. Then we have, and then the final thing, of course, you need to design good teaching capsules and modules. It's very important because you have to, and that's when we have to work with teaching specialists, because how do we transfer this knowledge that is complicated to a student which is learning? It doesn't have such a physics learning background. So you need to design this, and this is a lot of work. Okay, so we got funding from this time. It's not like today, you know, the level of information that you could transfer through internet was not so fast and not so massive as it is today. So there were a lot of technical problems to solve, which today would be solved much easier, I would say. And sorry, some of the information is in Spanish, but the amount of funds, for example, the total cost of the project, 267 millions of pesos. If you divide by 1,000, you get more or less in dollars the amount. Okay, and these were 2-year projects, 2007 to 2008, and 2009 to 2010. And the first one was very interesting because we were invited to join a network of remote labs with under a project from the European Union. And there were professors which were doing the same things in Portugal, in Spain, in Germany, and Brazil. And it was very fulfilling to work in that project. I made a lot of friends, which we still, even though we have not done much since these years, but we still remain in contact. From Mexico to. Okay, these are some of the models that you can, the simulation software, the laws, okay? And here are some of the models. With the same software, you can quickly generate different models like these, okay? Okay, the characteristic of the software behavior, their motion behavior. And then we have physical models that can be easily input using graphic user interface or inputting text commands. Our numerical simulation, we use Runge-Kutta methods. And but you visually see how this thing evolves, how the system evolves, so you can tell whether your command is completed or it gets stuck because it doesn't have enough force or it doesn't have enough torque and so on. Okay, I just wanted to remind that all images in these presentations are from actual projects developed by a team, which I formed part of. I was leader of both projects that I mentioned. Okay. How much do we have time? Okay, I have several other. Okay. Okay. Okay, what can I show you? I have several videos. Perhaps here I'm going to show you an animation. This is a Fanuc robot. And we are using it to simulate a task. So the concept is before letting the student use the robot, you test it in this software. And the software is a high fidelity physics model. So it will obey the laws of physics. So if it doesn't have enough power to lift the load, and so it will obey the physics law, and it'll drop the load or do something according to the physics of the situation. Okay, but we have so let me show you, for example, how we the type of module that we use to teach students. So it's in Spanish, but so it has, the student has to do some reading, and he has to fill in some blanks, and it goes in explaining. And then once he does that, this system simulates a lifting device, a lift table, okay? And so once he inputs the data, the system will, and answers the question, the system will move according to what the instructions he gave it. It should move sooner or later. Oops, it didn't seem to move, sorry. Maybe this was not the right. But the thing is that to get an idea of how the teaching capsules and modules are designed. And so here's another one. This is rather long, so I'll just, no, maybe I'll do another one. This is the one. This is the one. We took this system to a museum south of Santiago. So in this case, the activity, weekend activity was to let children use it. So they would use it and learn how to operate it. So that's good because some of them would eventually end up in this kind of
Para ello tenemos 4 tipos de palancas.
The last, we attempted to develop this and have a massive usage of this kind of tools, and we did a lot of work. We trained, let me see, we trained many teachers.
Digo, acuerdo con algunos de ustedes. Por lo tanto, todo lo demás está corregido y lo tengo yo en un archivo. Así que, para no gastar como tiempo en esto acá, al final, quienes quieran se pueden acercar a mí y yo les mando la planilla.
And these required a lot of effort because you have to prepare all the materials and so on.
Sí, les puedo dejar mi correo, mi celular.
I will
¿Ya?
this
Se lo puedo anotar.
Now, how about today? Where are we today? Unfortunately, this is, maybe this, I should not say this, but in the year 2011, in Chile, we had an uprise of students, okay? And many technical and vocational schools closed for a long time, and education was changed. And all these kind of projects remained on hold. And so several years passed by, and of course I could not wait as a professor. I could not wait so many years. for the situation to resolve. So I moved on to other things, but these tools are still available, and parts of it I still use them when I go to do consulting and engineering projects to the mining industry or to the forest industry, because this type of technology is applicable in all kinds of industries, of course. And also, let me remind you that when we did these projects, we didn't have the tools that exist today for generating client-server applications, and the internet was not so powerful as it is today. So controlling a robot by the internet was really a task, was really a big task, because of course you don't want to give a command and have to wait 5 minutes for the command to be resolved. Okay? So that's all. Thank you very much for your attention.
Thank you very much. We do have time for 1 or 2 questions.
Okay, your presentation, thank you for your presentation. It brings me back also to some experience I had years ago in robotics and remote lab. How did you deal with safety in combination with a robot, an industrial, or even a smaller robot, in remote in a remote lab?
Okay, well, safety. The first thing is that we burnt a lot of, not a lot, but several robots and several machines.
Okay.
Just in the implementation. And also when we ran these things, there was nobody near the robots. They were completely controlled. Once the user took control by his user interface, nobody was needed to be close to the equipment. So we never really had an accident, but we did burn a few equipment.
So the safety of the robot itself, it could hurt itself, let's say, or but not the people.
Yes.
Okay, but there were no, let's say, extra software that was monitoring whether when something got wrong or connection was broken.
Because in the control software, the governing software, usually we ended up in a PLC, for example, and the PLC had lots of sensors going in. So if, for example, if the current of a motor went too high, it stopped immediately. Or if the command was attempting to go out of range, it immediately advised the user, and so on. So the software was very rigorous in that sense.
Okay, thank you.
Mm-hmm. Thanks.
Using a simulation and later on doing like the real work or the real machines, since operating with them on the knobs, on the buttons and so on, it's different than, for example, using a simulation.
Yes, but we did everything we could so that the difference, which of course would exist, but wouldn't be so different. That's why it's physics-based. That's, I think, the key part in this work. It's not just pictures or motions. Its third would be to run the simulation software, and the fourth would just study from a book. And so we had all that kind of input. Unfortunately, in this country, the technical education is not, I mean, it's not one of the main goals of the education system, because the number of students is not so large, and so on. So I think that this kind of project to be able to launch and become massive require a big support from the government, and that's very difficult here because you have to compete with too many needs of the education system and of the society in general. So, and these things, even though you make these equipment available, they still are expensive. I mean, it's not. I'd say 90% of the technical schools, or 99% of the technical schools, would not be able to afford it unless the government puts them available, makes them available. Okay.
Thank you again. And while we change the technology down here, I would like to introduce to you the third speaker, even though introducing the third speaker to you might be a stretch here because you all know him already. So we are very pleased to have Doru Orsuzio here with us, OE. So with this, thank you very much, Doru, for being here. We are looking forward to your talk. And I would say, take it away.
I lose in last moment my label, but you have it here. Yes. I came from Romania, and I want to start with a short story. In 2004, with Michael Auer, we stay and drink one whiskey, and we discuss about the conference. And my proposal was to start a conference in the field of virtual instrumentation, and Michael put remote engineering. And appeared the conference, REV, Remote Engineering and Virtual Instrumentation. In 2000, after 20 years of REV, we changed it to a STEC conference. And in Brasov, we meet in 2005, 11, and in 2026. I hope all these people will be there. In Brasov, we build a center for verification and transfer of competencies inside the Faculty of Electronics, yes. And for many years, this center, it's obtained the money himself. We don't ask from the government or from the university. We are able in this center to have the money from different actions. I put a long title, why? Because about me, the start is online technology and virtual instrumentation, where we using sensing, monitoring, medicine industry, and now we add what is actual and modern cloud instrumentation and IoT, and put all these things together in Brasov in Romania. We started to think at international level. And in international level, we built the Remote Engineering and Virtual Instrumentation Conference. We start in 2005 the International Association of Online Engineering. IAOE have a lot of conferences and publications, yes. And now we discuss about STE 2025 here. I am very happy to be here. First time in your country. Was very pleasant for me, and I hope to do the same for you in Romania. At the national level, I explain it, we start with the Tempus project, yes, and we build Center for Verification and Transfer of Competencies with very strong companies from Europe. This was very good for us because we learned from these companies. For example, Teucos from France was the best engineering office and offered the permittivity to fly Ariane rocket, yes? And we visited the factory, we visited the engineering office and learned a lot of things. And for this reason, the Center for Verification and Transfer of Competencies work very well. You see here, we have a lot of partners. If you came in Romania now, we don't have this poster because the rector decided to don't be on the corridors these kind of posters, yes? But inside, you see, this is the creativity laboratory. You see on the table, there are all the new technologies. We put everything for the student, and every day I try to find some new modules and some new devices for the students. And in very good collaboration with industry, we receive many of them. You see on the walls, there are a lot of posters, yes? In every poster, there are 2 companies. Contorizate how many companies they are partner of our creativity laboratory. And here there are some short examples. What we're doing in CVTC, putting industry, education, school, and university together. All the time the teachers from university speak, I cannot teach my students because they came from high school not very well prepared. Why? We don't collaborate with the school. We do it. When we go in industry, people from industry speak, oh, your student is not so good. We collaborate with industry to have good students and to be very well known. And our target was to do education. You see, to research and development, innovative products, low price. This is very important because you can do a lot of good things, spend a lot of money. But why we can do good things, don't spend a lot of money. High functionality. And I remain on this device. Only about this device I speak. In 2014, this device win in Germany the design of Germany. Yes? Best design solar lamp. And this was done in CVTC for Steinel company, and president of the Steinel asked me, Doru, I need a lamp to work 15 days without sun. After to put some special activity application, and when there are a little sun to start again to work. We do it to work without sun 2 or 3 weeks without any problem. And everything in this lamp, starting with the solar panel and so on, was decided by us. We discussed in China with the company and built exactly the solar panel asked by us. And I have it from 2014, 3 or 4 in my house, never stop, never, from 2014. Local and remote system and university-industry collaboration. This is our target, and we succeed to do it. When I teach students, and I teach in university, I try to cover these 2 extremes. Homo sapiens, everybody stay with that phone in the man, and do something. Or this one. This lady, they are from Romania. And this lady also must go and work with electronic system. And I trained ladies, 64 years, I train in LabVIEW in 4 hours and do everything in LabVIEW. In actual context, we see many new technology. We see interaction, software, hardware, virtual instrumentation, yes or not. Some people don't like virtual instrumentation. For me, it was a big surprise. I discussed with one person from National Instruments now, and speak, Doru, virtual instrumentation is obsolete. I was surprised. I cannot speak, speechless. How National Instrument can speak something like this? Smart technologies. Everything is smart now. If we add artificial intelligence, it's clear. And we try to apply in all places and use this new technology, and very important to teach our colleagues, to teach our students, to teach our industrials to use. Amazing, yes? And the solar lamp for Steinel was done with Cypress system. And what happened? National Instruments was by Emerson. And now spread in many places LabVIEW software. This means we have a good intuition. Cypress was by Infineon, and also start to work in many fields with system controller from Cypress. And when appear different modules, we very fast implement in our laboratory, very fast offer solution to the students. And for example, there are some contests in Romania for the children. And every year I offer this kind of boards like gift from the children in part of CVTS. Yes? This is very important in this moment. We cannot speak only ASIC or SOC or FPGA or code or without code. We must put all the things together. In this moment, if we don't sustain the combination of these things, it's not good. Before, someone worked with ASIC, someone with FPGA, but now inside the same programmable system on the chip, there are an FPGA and 3 or 4 microcontrollers. Virtual instrumentation. Why we promote National Instrument software? Because it's very easy to learn, very fast to use it. Yes, panel, diagram, and build very easy. Yes, and we offer by this software a lot of things. I have 74 years. Yes, I don't know C or Python or something, but with LabVIEW, I implement C in LabVIEW and I use it. I don't know artificial intelligence, but I read now and I use it. Because again, they are a graphical programming solution in this field. And everything go very fast in education. You see here, it's an example in how many places National Instruments was used. In my start in collaboration with National Instruments, they offer some grants for university, but right for American university. In 1 year, they change a word, like American university. And I apply, and I speak my university is like your universities. And I obtain a grant, and all the NLV system in my laboratory is from National Instruments free. A lot of how using technology, how using software, how choose one software or other, one hardware or other, how develop the software, how reconfigure the hardware. About me, it's a mistake now to put everything in one hardware and to don't think reconfigurability of the system. Because tomorrow your client asks to be something in plus. And you repeat the whole design? No. You improve the software and everything is very good. How to make the software reusable? You don't invest a lot of effort and do something, and after you don't use it. No, tomorrow use the same and you improve it. And to add up all these questions, add cloud instrumentation, IoT, and artificial intelligence. Devices and development. You see here some example what we do it. For example, this kind of device here, oscilloscope, voltmeter, and so on, was done by a student in 4 hours. 4 hours. This means understand Cypress, understand how to program, and do it in final shape. I presented this in the United States. And Patrick came from the Cypress, picked Doru, borrow me this device because I have other 2 conferences I like to present. And I borrowed to the Cypress this device. IQRF, a very nice company from Czech Republic, young people. I go in and they push me in restaurant till 10 o'clock, and in the morning at 8 o'clock ask me, you do an application in LabVIEW? And I smile and I speak yes, and can control it. And from that moment I collaborate with this company very well, and I receive a lot of devices for my students. Smartphones, yes, we must use all this facility. And you see, with a small board from IQRF, we can control the light. Why? Steiner asked me I want to control all the light in your room and to have here on the table 500 lux. And I build with this in a few days all the system. Control in LabVIEW. You see the system IQRF in LabVIEW, and here you can put the power. I put only for exemplification this, but you can control the system of illumination in the room. My colleagues from Faculty of Music asked me, Doru, you have a lot of idea what we can do in Faculty of Music like master. And I suggested a master in music therapy. Why? Because music therapy put together music, medicine, and us, engineers. I am physicist, that is the same. And you see here the master in melotherapy. Yes, it's like a bridge between medicine, music, using the science. The students from this master came and speak a lot of non-scientific idea. And I try to modify their modality of thinking to be scientific. They came with a Tibetan ball. And they speak, Herr Professor, this Tibetan ball have two very important frequencies. I look at the ball and I speak, no, have only one. I build an application in LabVIEW together with the students, and in 5 minutes they see it's only one frequency. It's very easy. And we put together physics, software, hardware in melotherapy, and we try to build a scientific knowledge. We detect this system in the market. It's a very good one. Why? Because satisfy everything I need from a system. It's reconfigurable, have driver in LabVIEW, can be controlled in LabVIEW. Sensibility is very good. You can measure any biological signal, and you can use it to calibrate the results in melotherapy. You see here what you can do. It's very good device, and our students use it to calibrate their devices. You see here the dimension, and you see 1 microvolt, and you see the resolution in 24 bytes, very good one, and everything can be reconfigured. You have a small component of software, and you reconfigure this box to do what you want for you, this box. And this is the application of this box. If you look there are a lot of engineering, medical application, all the medical list. Because you can reconfigure the system how you need it. And here there are some of application, and what we do it with the students and try to offer them support, physics support, informatics support, electronic support, and to measure something in the field of music therapy. And here is another surprise. I have classes with these students from musical therapy, and they don't have any baggage of knowledge in electronics, physics, or something like that. Some of them, they are psychologue, some of them, they are musicante, they play instruments and so on. And because they are very happy, I propose we, 4 and me, 5, want to write a publication in international journal. In 2 laboratory work, we do it, and appear in 1 international journal and in 1 book. Everyone receive a task, and we do it directly in the laboratory. And here is the results. You see example, how, you see the red curve, what happened when you hear some special music. Yes? But my rector, and second, my rector is a very clever one. Was a big mistake, cannot came with me, because he's also vice president of Council of Director in Romania and have a meeting, cannot came here. But it's very clever. In one day, speak Doru, I came in laboratory, I want to see something clear with melotherapy. I tried to do a PowerPoint presentation, speak, no, speak director. I want to make a demonstration on me. Okay, I put one wave system with 2 electrodes here, and I ask 3 minutes, 5 melody. And when I finished, I speak to you, what melody affect you more? I put the melody, and I speak, Rondo Veneziano is the best melody for you. And the guy look at me, put the hand on the table, you can do what you want in melotherapy, and go out. This means to convince people about real results. Infineon and Cypress now produce a board, PSOC 6, for artificial intelligence, a small one, and you see what is inside, what you can do with this kit. It's one of the most beautiful recent kits on the market. You see here, 3.5 centimeter, 4.5 centimeter, and read what they can do it. And you can program this system graphically, and you can implement artificial intelligence graphically. Now I learned these kind of things, and I can do it. Yes? DeepCraft. This is the graphical software for artificial intelligence, free. You can enter, you can download it, and you can use it. And here, how you construct your model and so on. And I succeed to do it in 2 or 3 days. In 3 days, without any knowledge about artificial intelligence. I acquire the signal, I put the labels, the software recognizes the signal, and I develop a model, and I use it. This is the interface graphically. Oh, I don't want more information because the time is limited, but it's graphical like in LabVIEW. You drag and drop and connect devices, and you can do artificial intelligence. Yes? And many thanks for this introduction, and I want to speak something about the next conference in Brasov. There are some external sustaining companies and normal sustaining of Transylvania University. Romanian support. Till now, I succeed to discuss with all this company and to obtain the guarantee will sustain us for the state conference. Sustain, not offer money. But first step is to sustain, second step to store some money, third step is to put them to be investor. And normal, my Academy of Romanian Science, Academy of Technical Science, where is Professor Samoilă, who is with 10 years more like me, and we work in the same laboratory, in the same office from 35 years. And university have a very nice new aula. In 2011 and 2005, we do the conference in the nightclub. This time we move in the aula. We have very good facility with exposition and so on, and companies can build exposition. And now I ask to put a short movie, 3 minutes movie, in which you will see what is in my university and hope to see everybody there. Thank you. faculties, a mixture of faculties. This is a rectorate, it's a historical building. This is the biggest research facility in Romania, built with European money, 30 million euro, and university put 15 million. See, 12 buildings with devices. Daula.
Thank you also for your talk. We do have a little bit of time for questions, if there are any. I mean, the video was at the end, but shouldn't prevent us from having questions, right? I think we can leave it with that. So thank you very much, Dorum. We are looking forward to next year. This now concludes our third keynote session. Please let me thank again all three keynote speakers. Thank you for coming here. Thank you for presenting, for preparing the presentation. Thank you for asking questions. We are now going into our lunch break, which is a little bit shorter than the previous days. It's only 1 hour. And then we will go into our last sessions. And then beware, after the last session, we will continue with the closing session right away. So there's no break between the next session and the closing session, but there will be coffee after the closing session. And also for the closing session, we do have our best paper award presentation. So I urge you to come and be here with anticipation. So, but with this, oh, okay. With this, thank you again for being here. I wish you a nice lunch, a nice last session, and we will see each other again for the, at latest for the closing session in this very room. So thank you very much.
Just last